Dear students, the subject Computer Fundamentals, and in the previous video we have discussed about the number system and we have discussed the decimal number system and binary number system. In today's class we are going to study about the octal number system. So first we will understand what is the meaning of octal. Octal means it is 8. So as the name itself suggests, so the base of octal number system is 8, and if you remember the same concept, the symbols that are present in this range from 0 to 7. The single digit or the smallest single digit will always start with 0, and the largest single digit present in this octal number system is 1 less than the base. So base is 8 here, so the largest single digit should be 7. But total number of digits or total number of symbols that are present in this number system are 8. Now, as you have discussed in the decimal number system and in the binary number system, we will be having the positional values for each individual digits. Like in the case of binary, we have the positional values with 2 raised to 0, 2 raised to 1 and so on. In case of decimal, we had the powers with base 10. Similarly, in case of octal number system, each position in octal number system represents a power of the base 8. So that means if I have a number by using the combination of these digits or symbols, the positional values will start with 8 raised to 0, 8 raised to 1, 8 raised to 2 and so on. So the concept is going to remain same, but depending on the base, the positional value will be different. And as we are dealing with the positional concept, octal number system or octal numbers also belong to the category of positional numbers. So let us take simple example to understand this octal numbers. So if I want to write a octal number, I can use the combination of digits present in this symbols or present in this number system. So I can write any combination of number with this. So I can write 44, I can write 56, I can write 104, anything I can write. But remember that if I don't specify the base, by default it will be considered as decimal. So always better to write the base. So if I specify the base, then it will be more clear and it will give meaningful information. So it's always better to write the base. And all these numbers that are written on are the valid examples for the octal number system, because I am using the digits or combination of digits that I have written here all belong to this digit set or the symbols. There is no digit which is like 9 or say 8. So if I write a number like for example 98, or if I write a number say 18, okay, or 99, and if I specify it as base 8, then these are the invalid examples for the octal number system, because I am writing the base as 8, but I am using the symbols which are not present in this number system. So 9 and 8 are not belonging to this number system. In case of this, 1 belongs to this, but 8 does not belong to the octal number system. So these are the invalid examples, and these are the valid examples for the octal number system. So it depends on the base, and we can easily try it out. So now if I want to if I take a number and if I want to find the decimal equivalent of that number, we need to follow the same procedure that we did with the binary numbers. For example, if I have a number say 44 to the base 8. Now if I want to know the decimal equivalent of this, what I need to do? I need to take the positional values, so and we need to multiply it with the digits present in that respective value. So I will take 4 into 8 plus 4 into 8. So only 2 digits are present. So at the rightmost digit, I have the positional value with power 8 raised to 0, and here I have 8 raised to 1. So now if you calculate, 8 raised to 1 is 8, 8 into 4, 8 into 4 is 32, plus 8 raised to 0 is 1, 1 into 4 is 4. So now this is equivalent to 36 to the base 10. This is 36 to the base 10. So this is the number 44 to the base 8, and its equivalent value in decimal is 36 into 10. So if you remember, the concept is going to remain same. Take the digits and multiply with the base and with respective powers present in that positional value. So 8 raised to 0, 8 raised to 1. So again, all these are having some positional value. So we can conclude that octal numbers also belong to the category of positional number system. So let me take one more bigger example, and so that we can convert that octal number into the equivalent decimal number. So the example is 2057. 2057. So I want to find the equivalent value of this octal number into decimal. So again, take this individual digits, 2 into 8 plus 0 into 8 plus 5 into 8 plus 7 into 8, and then put the powers. So powers for this will be always starts with 8 raised to 0, 8 raised to 1, 8 raised to 2, and 8 raised to 3. So now if you calculate this, it will be equal to 8 raised to 0 is 1, this will be 7, plus this will be 8 raised to 1 into 5, 40, then this will be 8 square, but this will be 0, and then 8 cube will be 512, and this will be 2. So this will be equivalent to 1024 plus 40 plus 7. So I can write this 40 plus 7. So this will be equivalent to 1071. So this is 24 plus 40. So this will be 64 plus 7. This will be 1071. But we need to specify the base. So the base will be equivalent to 10 here. So this is how we can convert octal number into the decimal number. So that's all we have with respect to the octal numbers. We are going to study about the next topic, that is the hexadecimal number system. As the name suggests, hexadecimal number system, we have total 16 symbols in this, or we can say we have 16 digits in this. So hexadecimal, so deci means 10 and hexa means 6. So we are having 16 symbols in hexadecimal number system. So when we have this hexadecimal number system, we require total 15 digits, and if you remember that the smallest single digit will always start with 0, and the largest digit will be 1 less than the base. So the base for hexadecimal number system is 16. So 16 is the base for hexadecimal system. So now we will look into the different digits that are present in the hexadecimal number system. So initially from 0 to 9, 10 digits are represented with 0 to 9, which are similar that we have in the decimal number system, and after that we should have total 16, but here we are having only 0 to 9, which will turn out to be 10 digits, and after that whatever numbers that we have for 10, 11, 12, 13, 14 and 15. So for this we don't use these numbers like 10, 11, 12. Instead of that we use this alphabets A, B, C, D, E and F. So if I am having a number say 1A, so if I have a number in hexadecimal number system 1A to the base 16, so this means that this one is equivalent to this, and this A means which is equivalent to 10 that we use in the decimal number system. So in case of hexadecimal number system, we don't use 11, 10, 11, 12, 13 and so on. So for after we get completed with 0 to 9, we use A, B, C, D, E and F. So now if you remember the concept, the smallest single digit in the hexadecimal number system is 0 and the largest single digit is F, which actually means what? 15. But the smallest digit is 0 and the largest digit is, or the largest symbols we can say. So that's why we are referring these as the symbols. They need not be digits itself. They are just called as the symbols. So they can be digits or they can be alphabets. But in case of binary and octal and decimal, we have only digits. But when it comes for the hexadecimal number system, we are having base as 16 and the symbols that we have, total 16 symbols we should have. So these are the 10 initial symbols, and then for remaining 6 symbols we use this A, B, C, D, E and F. So the smallest digit is 0 and the largest digit, or you can say symbol, the smallest symbol is 0 and the largest symbol is F. So now F is 15, which is 1 less than the base. So 1 less than the base. Now let us understand this. So each position in the hexadecimal number system represents a power of the base, that is 16. So in the earlier case, if you remember, in binary we have 2 raised to 0, 2 raised to 1 and so on. In case of octal we had 8 raised to 0, 8 raised to 1 and so on. In case of decimal we had 10 raised to 0, 10 raised to 1 and so on. So the positional value in case of hexadecimal is with the base, that is 16. So we will have 16 raised to 0, 16 raised to 1, 16 raised to 2 and so on, it will continue. So for any combination of number that we do by using these symbols, we should multiply that position with that digit or symbol with the positional value. So this is what we need to use it. Now let us take some example to understand this concept, or how we can convert this hexadecimal number into the normal decimal. So before going to that, to give some more examples, I can say like 34. Okay, I can write it as 58. All these are the valid examples. But the question arises whether it is the octal number. So if you consider only 34, it can be octal number, it can be decimal number, it can be hexadecimal number, because all the symbol 3 and 4 are present in octal, they are present in decimal, also they are present in hexadecimal. So that is why we need to give the base properly. So now if I specify the base, now we will refer that this is, like this we need to represent it. So now 58 if I take, I need to assign it with the base. So, or to give few more examples by using these symbols and like A, B, C and so on. So for hexadecimal number I can write it as 2F, okay, to the base 16, okay, or I can write AB to the base 16. This is also a valid example. So each digit will be considered as a separate entity. Suppose if I have something say like 11 to the base 16, okay, so this doesn't mean that we are referring it to B, because everything or every element will be considered as a single digit. So this one we have considered, and again this one also means this. So together we should not consider it as B. We are making some mistake here. Or if I have something say 12 to the base 16, both digits we should not consider together. We should consider each digit separately, because we don't have any symbol like 11. Do we have any symbol like 11 in this? No. We have only symbols from 0 to 9, and when I want 10, 11, 12 so on, I use alphabets A, B, C, D, so on up to F. So this is one more important thing that you need to remember. Now let us take some examples and try to convert this with the decimal numbers. So let us take this simple example 1AF. Okay, so if I want to convert this problem or this example to the base 10, or if I want to convert into the decimal number system, what only I need to do? I need to consider each digit separately. Like in the previous case what we have done, same thing we need to do. So 1 into, what is the base? 16. 1 into 16 plus, now here I have A. So what is the value of A? I cannot just take A and multiply with 16. So it will not give any value. A means 10. So I need to take 10 into 16 and then plus F. F stands for 15. 15 into 16. So always the powers will start with 16 to the power 0, 1 and 2. So when we are just dealing with octal numbers and decimal numbers or binary, calculation of this becomes easy. Otherwise you can use the simple calculators. Simple calculators are allowed for this subject. So you can take simple calculators and you can calculate it. It becomes difficult for you. So now this value we can write it as 16 raised to 0 will be again this. So we can write as 15 into 1 and then this 16 raised to 1 is 16 plus into multiplied by 10, sorry. So it will be 160 directly we can write, or just 16 into this, and then we can have this 16 square. 16 square is 256. So 1 into 256. So the total comes out to be 256 plus 160 plus this is 15. So together if we add this 256 plus 160 plus 15, so it comes out to be 431 to the base 10. So this is how we can convert a number that is present in the hexadecimal number to the decimal number. So you need to take each single digit separately and multiply with the powers. So whenever you have alphabets like this, if you have alphabets like this, try to take what is the actual value of it. Here I have A. If there is a A, that means you need to take 10. If there is a B, you need to take 11. Okay? And in other cases, when we don't have any symbols, when we don't have any alphabets in the given question, directly we can take the digits. We can try with one more example for that matter. So I hope this is clear to you. So every digit has got a positional value, and that positional value will be decided by the base that we have. So in the hexadecimal we have the base as 16. So each digit will be multiplied with 16 and respective powers, so that we can get the result, and this we can call it as the conversion from the hexadecimal to decimal. Now we can quickly take one more example. So I can write it as B2 to the base 16. So this is also a valid example for the hexadecimal number system. Now if I want to convert this, what I will do? B, or you can write one more step. Just write B into 16 plus 2 into 16 raised to 0. This will be raised to 1. So here I have B. B means what? B is equivalent to, what is the value of B? B is equivalent to 11 into 16 plus, this will be 16 raised to 0 is 1 into 2. So this will be 2. And now 16 into 11. 16 times are 160. 160 plus 16. 160 plus 16 will be 176 plus 2. So this will be 178 equivalent to the base 10. Just verify the answer. So B is equivalent to 11. So 16 into 11. How we can simplify this? 16 into 10 is 160. 16 ones are again 16. So 160 plus 16 will be 176. Orally also you can do, this will be 2, so this will be 178 to the base 10. So these are the few examples for the hexadecimal numbers. Now if I have a number say like 23, or for example the same previous example, if I consider, if I have an example say 11 to the base 16. Now you don't take this as a single value, you need to take it as separate digits. So if I want to convert this, what you need to do, you need to take it as 1 into 16 plus 1 into 16. So 16 raised to 0, 16 raised to 1, and so on. You can try doing it. Or for example, if I have a number say 13 to the base 16. So again you should not consider it as 13 into 16 to the raised to 0. So you are making some mistake here. You are going wrong. So what you need to do is, you need to consider each symbol as a separate entity or a separate symbol. So again for this, you need to consider it as 1 into 16 plus 3 into 16 raised to 0, this one, and then you need to solve it. So these are the some examples that we have with respect to the hexadecimal number system. So now in a nutshell, we have discussed all the different types of number system that we have. So we considered first initially the positional number system, and also we discussed about the non-positional number system. So in case of positional number system, every digit or every symbol will have its positional value, and that positional value depends on the which number system you are using. If you are using binary, the base is 2. If you are using the octal, the base is 8. If you are using decimal, the base is 10. And if you are using hexadecimal, the base is 16. Depending on what base we have, we will be having those many number of digits or the symbols. So the number of digits or number of symbols is always equivalent to the base, and the smallest digit will always start with 0, and the largest digit will be always 1 less than the base. Same thing we have studied in case of binary. So in case of binary, we have only two symbols, that is 0 and 1. So the base of binary is 2, and for octal the base is 8, and the symbols are from 0, 1, 2, so on up to 7. And for decimal, the symbols, the base is 10, and the symbols are from 0, 1, so on up to 9. And then for hexadecimal, as it is present here itself, we have total 16, the base is 16 and total 16 symbols we have. So 0 to 9 is first set, second set is from A to F. So this is all basics things are required to deal with the conversion from one number system to another number system, and vice versa. For example, we can convert from hexadecimal to decimal, octal to binary, and binary to decimal. All these conversions we are going to take up in the next class. I hope you have followed it. Try to write down all this in your notebook and practice few examples of this kind. Thank you all.